All right, we calculated our RPMs and we came up with 492 RPMs as the recommended number. But like I mentioned, we're gonna go to the lower setting in our options here because 550, I do believe that without any coolant, we would probably see brown chips shortly after getting the drill bit started in the hole. So to get to this 400, this is 400 RPMs, we need to be in, the lever needs to be in the B setting, which actually this lever currently is. And we need to be in 1 and C. So up here on this lever up here, I have D and C. So in the up position, I'm in C. And then the 1, we have 1, 3, 2. So now this lever is in the 1 position. So if I have this machine set to where when I turn the spindle on, it'll be rotating at 400 RPMs. There's just one more step that we need to take before we start drilling the holes in this plate, and that's going to be to set the feed rate. We want to use the power feed instead of using our arm strength to drill holes whenever possible. It's actually going to be better on our cutting tools using a controlled feed rate than using the variable feed rate that our hands are going to give us. You will actually find that getting a drill bit started into a pre-countersunk or center drilled hole like this can become problematic if you're feeding in by hand. But if instead of pushing down on my levers to feed the drill bit, if I pull them outwards, I will have locked the spindle into power feed, and then the motor will be driving the drill into the workpiece. As soon as you start talking about feed rates or power feed, then now you have to look at the feed rate, the distance that the tool is going to move in the downward direction per every rotation of the spindle. We're going to go at a very, very conservative feed rate to begin with, because if you're new and things start to go bad, I want you to have more time to react to simply disengage the feed. So on this machine, the fastest feed rate it has is 0.012. That's 12 thousandths of an inch. Think of it as 3 sheets of paper's thickness that the drill would go down for every full turn of rotation. With my students, I like to take it really easy. I go at either the 4 thousandths or the 8 thousandths. And the 4 thousandths is underfeeding it. But you can use that if you want. The depth stop isn't meant to be something to where you just basically shut off mentally upstairs. What it can do is it can be set in place so you can perform several holes to the exact same depth, or have it stop as you come through the bottom of your plate in the event that you get distracted, or to make it a lot more difficult for you to drill into your table or your vise. So the way that the depth stop works is, first I'm going to position the tip of my drill to where it's close to the surface of the plate. And it doesn't have to be perfect. It just needs to be approximate. Now, on this machine, I have a little mark right here, and it says set depth. Then I have this collar that goes around the outside, and if I loosen the little jam nut, I can spin the collar. And on this collar, right here, it says depth 0, and then there's a 1 inch, a 1.5, a 2 inch. You get the point. What I want to do is, I want to line up the number marking here to my mark down here, my set depth, for however far I want my spindle to travel from its current location. So I have a 3/4 inch plate, and then I have approximately a 1/4 inch from the surface to the full diameter of my drill bit. So 3/4 plus 1/4 is 1 inch. So I'm going to go ahead and I'm going to move the collar marking of 1 1/8 inch to my set depth, and then clamp it down. Now, what that's going to do is as the spindle goes down, this mark, my set depth mark, is getting closer and closer to the 0 that's on the other side of the 1.125". When the 1.125" gets to this spot, the feed arms will automatically disengage. I'm going to apply some cutting oil, and notice I have the surface area of the table. It's clean. There's one little block of wood, I can move that as well. I don't want a lot of stuff on the table. As the chips start to form and they come up the flutes of the drill, I'm going to occasionally disengage the feed and then re-engage the feed. That momentary pause in feed force will let the chips break and they'll fall to the side, and then it will continue to feed down. If you feed without stopping and you never break your chips, well, then you can end up with big 3 feet long chips swinging around here. They could cut you. They make a mess. It's just a bad idea. Chip control is a big part of machining. Your chips tell you a lot about what's going on with your cutting action. So we're always paying attention to our chips. All right, let's go ahead, turn on the spindle. That's the correct direction. To me, that looks like it's probably the right RPM. So I'm gonna turn it on. I'm gonna bring it down close to the part. I'm gonna engage the feed. It's gonna squeak a little bit at the beginning. Or chatter. Now it's gotten quiet, and I broke the chips. And I break the chips again. Now notice those chips are silver. And if I want, I can add some more cutting oil. I move the drill bit away. But you just break the chips when they start to become long. Now the chips just turned brown and a little blue, so I'm breaking through. Now I can look at my set depth, and I'm through the plate right now. And then it disengages the feed arms, so I can raise the spindle up. When you start to break through, you want to time it, if possible, to where you can feed all the way through. Because what can happen is if your drill bit's starting to clear all the way through the bottom and then you come away, then when you come back down, if you bump the bottom, it can almost want to pull the drill bit through. It's more likely with certain materials, and it's something that basically you'll just experience, and then you'll start to figure out, like, oh, that's what I'm trying to avoid. All right, so we got our 4 drilled and tapped holes in the plate. This drill bit tip by this point is pretty warm, so be very mindful. Your cutting tools get warm as they remove material.